The belief that humans only use 10% of their brain is a common misconception. Neuroscience shows that all brain areas are active to varying degrees. Techniques like fMRI and PET scans demonstrate widespread brain activity. Different brain regions have specialized functions and work together in networks. Brain activity is distributed across various regions, not confined to a small fixed percentage. Specific tasks activate particular brain regions, demonstrating functional specialization. No brain area remains consistently unused, highlighting the brain's dynamic nature. Neural pathways strengthen with repeated use, illustrating brain plasticity and adaptability. Dramatic increases in brain efficiency could lead to significant cognitive improvements. Enhanced memory function would allow for more efficient information storage and retrieval. Processing speed could increase, enabling faster analysis and decision-making. Improved multitasking abilities would allow for handling multiple tasks simultaneously with greater ease. These enhancements may stem from optimized neural connections within the brain. Faster information transfer between neurons could also contribute to cognitive gains. Enhanced sensory perception involves a heightened ability to process environmental information. This allows individuals to perceive subtle details and patterns that are typically unnoticed. It may include increased sensitivity to stimuli like light and sound. The result is a richer and more detailed sensory experience of the world. Telekinesis, the ability to move objects with the mind, is currently a speculative concept. Hypothetically, it would require direct brain interface with external devices. Alternatively, it might involve manipulating electromagnetic fields to affect physical objects. Such abilities are theoretically possible if these interfaces or manipulations could be achieved. However, based on current scientific understanding, telekinesis remains highly improbable. Precognition refers to the purported ability to predict future events. Currently, there is a lack of scientific evidence supporting the existence of precognition. The human brain is adept at pattern recognition and prediction based on past experiences. However, this ability does not equate to accurately foreseeing the future. Enhanced cognitive abilities may improve predictive modeling. However, they do not grant the capability of actual precognition. Telepathic communication, defined as direct mind-to-mind communication, is currently not supported by neuroscience. Brain activity relies on electrochemical signals, which do not inherently transmit thoughts to other individuals. Current technologies focus on interpreting brain signals rather than enabling direct telepathic transfer. These technologies may facilitate communication, but not through direct mind-to-mind processes. Significantly enhanced cognitive abilities could trigger profound societal changes. Education systems would likely adapt to leverage these new capabilities. Workplaces and social structures would also evolve to accommodate enhanced cognition. This could potentially lead to advancements across science, technology, and the arts. Extremely high-rate information processing could lead to overstimulation. Information overload would become a significant challenge. The brain's capacity to manage sensory input would be tested. Maintaining focus would require new cognitive strategies. Effective coping mechanisms would be essential. Failure to adapt could result in cognitive exhaustion. Cognitive enhancements raise ethical questions about fairness and potential misuse. Equitable access to cognitive enhancements is a crucial consideration. Preventing discrimination based on cognitive abilities is essential for social justice. Ethical guidelines are needed to govern the development and distribution of cognitive enhancements. The potential for misuse of cognitive enhancements must be addressed proactively. Maintaining a balanced society requires careful consideration of these ethical implications.